Okay, so today we are going to solve some of the numericals regarding work, power and energy. So let us see what are the given questions. So first of all, what is given? Just see F is equals to 2I cap minus J cap plus 4K cap. So what is the force given? We can see F is equals to force given. It's a vector quantity. Force given is equals to 2I cap minus J cap plus 4K cap. And it displaces a particle D. What is the displacement of the particle? 3I cap plus 2J cap minus K cap. Now, work done, W is equals to how much? F dot D. W is equals to F dot D is equals to 2I cap minus J cap plus 4K cap. That is, we are going to multiply with 3I cap plus 2J cap minus K cap, right? So when we are going to do this, why we are doing this? Because work is a scalar quantity, that is F dot S or F dot D. We do dot product. So when we do this, it's very easy. 2 into 3, that is coming 6 minus 2. J is getting multiplied with J. 4K cap is getting multiplied with this minus 4. This is this K cap. So after multiplying, so what we are doing, just see 2 I cap getting multiplied with I cap, J cap getting multiplied with J cap, and 4 cap getting multiplied with 4 cap, K cap. I hope this type of numericals we have already done before. That is W is equals to, we are getting 6 minus 2 minus 6. So W is equal to coming how much? We are getting 0. So here 0 work done we are getting. We are getting 0 work done. Okay. So if this is the situation for this type of numericals, you are going to do in this way. What about if the question gives you something like this? What is the question given? F is equals to 3x square plus 2x minus 7 acts on a 2 kg body, as a result of which the body gets displaced from x equal to 0 to x equal to 5 meter. The work done will be how much? So for this type of numericals, what we do, work done is equal to integration what? F dot dx. Work done is equals to integration F dot dx. Why are we doing F dot dx? Because we can understand this is displaced from x equal to 0 to x equal to 5. That is, it is work is being done in one dimension. Work done in one dimension. The work is done in one dimension. So when the situation is something like this, W is equals to F dot dx. So what is the initial point? 0. What is the final point? 5. So when we are doing this, W is equals to, what we can do here? Integration 3x square plus 2x minus 7 dx, x equal to 0 to x equal to 5. So when we are doing this, how much are we getting from here? We are getting, if I integrate this, I am getting 3x cubed by 3, 0 to 5, plus 2x square by 2, 0 to 5, minus 7x, 0 to 5. So W we are getting. So can you see one thing here, that this 3 and this 3 getting cancelled? So we are getting how much? 5 cube minus 0 cube plus 5 square minus 0 square minus 7, 5 minus 0. So if we do this, how much we are going to get? We are doing this, so finally we are going to get something like this. I'm writing here as I don't have space in this slide. So we are getting work done is equals to, we are getting 5 cube is how much? 125 plus 25 minus 7 fives are 35. So we are getting basically 150 minus 35. That is, we are getting W is equals to 1152. So which option is correct? Option 3 is correct. Clear? So this type of numerical, they, both these two numericals I have done here as a kind of contrast. One we are doing that directly dot product, because the vector quantities are given directly, as you can see they are given in the component form, xijk component form, and here f dot ds we are doing because here the force is a function of position. Here we are doing what? F dot ds integration. Clear? Next, this type of numerical. What are we going to do this type of numericals? See, here what is being given? Here it is given a force acting on an object with varies with distance as shown. The work done by the force in moving the object from x equal to 0 to x equal to 6 meter. So here, to solve this type of question, let me give you one tip. What is the tip here? Tip is that work done in force displacement graph, in force displacement graph. What is force displacement graph? We can see here. This is force displacement graph. Work done is equals to area under the curve. Work done is equal to area under the curve, right? That's what work done. Now, here we will find out, you can see this is a force displacement graph is only given, right? This is a force displacement graph is only given. So what are we going to do? We are going to find out this area under the force displacement graph. Because what is being told in the question? In this question, it is told that we have to find the work done when a body moves from x equal to 0 to x equal to 6. So in this situation, what I can do here, so you can find out the area. So area under the graph. So when are we doing area under the graph? When we have been given force displacement graph, work done is equals to area under the graph. So here we can see what? Total work done will be what? Area of the square part plus area of the triangular part, right? Area of the triangular part. So what is the area of the square part? Can you see 0 to 3 and here also 0 to 3. So 3 into 3, right? 9 plus area of the triangular part. What is that? Half. What is the base? Base is what? 3 and 6 is what? 3. And what is the height? Height is also 3. So here we get 9 plus this is 9 by 2, that is 4.5. So work done we are getting how much? 13.5 joule. 13.5. Okay. So that's what we are getting as the work done. So here which option will be correct? We are getting option 2 is the correct answer. Got it? Okay. Next, this question is really important, and this question is from NCERT. And see what we can do. What is being told? Here is a story we have to understand. A raindrop, we will consider this raindrop. Let's see. Consider this to be a raindrop. This raindrop is at a height. What is the height? 500 meter. Just see. So this question says this raindrop is at a height of 500 meter, right? So this is 500 meter. So you can understand when this raindrop is at such a height, what do you think? It has maximum potential energy. Potential energy is what? It's maximum. Potential energy is maximum. Now it falls with a decreasing acceleration due to viscous resistance of the air until at half its original height. It attains its maximum terminal speed and moves with uniform speed thereafter. So you can understand when this raindrop is falling from this height, when this raindrop is falling from this height, its acceleration is decreasing. Its acceleration is decreasing. Acceleration decreasing means does not mean that the velocity is going to decrease. Why? Acceleration means what? Velocity increases. So velocity increased, but a time has come when it has reached half the mark. when it has reached half that height, that is at 250-meter mark, the amount of velocity it reached, the amount of velocity it reached, that is called terminal velocity, that is the maximum velocity it reached. And then further, this raindrop carried on with the same velocity. Okay, so here you can understand like this, what is going on. The raindrop is falling, velocity increases. At this point the velocity increases to maximum. After that, this raindrop falls with constant velocity. Now here, this portion we have to understand, this is the portion for constant velocity portion. Let me just shade it in this way. This is the portion where the raindrop has fallen with constant velocity. Now understand, if raindrop falls with constant velocity, that means in this region kinetic energy is also same. Kinetic energy is also remains constant. Yes or no? Kinetic energy also remains constant. Now over here, it when it reaches at this point, it reaches with a particular velocity. What is the velocity with which it reaches? It reaches with a particular velocity that is given in the question. V is equals to how much? 10 meter per second. Okay, so we will understand this question again from before. A raindrop falling of radius 2 meter falls from a height of 50 meter above the ground. It falls with a decreasing acceleration until at half of its original height it attains maximum speed. So here at this point it attains maximum speed and moves with uniform speed thereafter. So this portion, it is moving with uniform speed as I have shaded. What is the work done by the gravitational force on the drop in the first and the second half of the journey? What is the work done by gravitational force in the first and second half of the journey? That we'll understand. And second, what is the work done by the resistive force in the entire journey? What is the work done by the resistive force in the entire journey? Okay. Now see, what we have to clear from here, total energy remains constant. Okay, total energy will always remain constant. That we have learned, right? Now the question is, when it is at height 500 meter, when it is at height 500 meter. So just see, at this situation, what is kinetic energy? Kinetic energy was zero. So when this ball has dropped from this highest point and reached over here, some of the kinetic energy decreased, and that amount of kinetic energy is being converted. Sorry, when this ball is falling from this height, potential energy is maximum. Some of the potential energy gets converted into the kinetic energy at this point. Got it? So let us understand. First, let us find out what is the mass of the raindrop. Mass of raindrop. How can I find? See, here radius is given. So in order to find out the mass, we have to understand mass is equals to what? Volume into density. Volume into density. So what is the volume given? 4/3 pi r cube, that is the volume. What is the density? Rho. This is mass. So 4/3 pi r. What is r? R is equals to 2 mm. And what is density? Density is 1 gram per centimeter cube, or we can use here 1000 kg per meter cube. Now why are we using 1000 kg per meter cube? Because we are considering in this SI unit. So if I calculate this, value, what we will see, 4/3 pi r cube. So mass of the raindrop we are getting, mass of the raindrop we are getting 3.34 or 349. So we are considering it 3.35 into 10 to the power minus 5 kg. Okay. Is it clear why we have calculated 10 to the power minus 3 here? Because 2 millimeter is given. 2 millimeter is given, that's why. Okay. This is mass given. Now, what is the potential energy at this height 200, 500 meter? So P max, so PE max, that is at height. What we do? mgh, right? mgh. So if we do mgh, what are we getting here? Mass is given 3.35 into 10 to the power minus 5. G, nothing is told, so we should take here 9.8. And what is the height? 500 meter. So we are getting, if I calculate this, we are getting 0.164 0.164 joule. This is the potential energy at this height. Okay. Now, when gravity is pulling, how can we find out when gravity is pulling? See, this is the potential energy at this maximum height. So when it falls down, from here, it is falling at this portion. Potential energy is reducing. Kinetic energy is increasing. So when it comes over here, so what is the potential energy at this portion? So potential energy at 250 meter height. What is the 250-meter height potential energy? What we will do? Same thing. Same thing. We will see here 3.35 10 to the power minus 5 into 9.8 into here. What is the mark now? 250. Just the half of it. So if I try to find out the half of it, we get how much? We get 0.082 joule, right? We get 0.082 joule. So what is the decrease in potential energy? What is the decrease in potential energy? This is the decrease in potential energy. So the question given, what is the work done by the gravitational force on the drop in the first and second half of the journey? You can understand for the first half of the journey, work done by gravitational force will be how much? The decrease in potential energy. Why? Because who is pulling? Gravitational force is pulling, right? So what we can understand, in first half, in first half journey, in first half journey, change in potential energy, that is equals to how much? 0.164 divided by 0.082, that is equal to 0.082 joule. This is what? That is equal to work done by gravitational force. Now we coming to the next part. What is the work done by the resistive force in the entire journey. Okay, what is the work done by the resistive force in the entire journey? So just see, in this entire journey, the total energy remains constant. The total energy is remaining constant, right? So if I consider at highest point P max, this is the highest point P max, total energy remaining constant if I say. So since total energy remains constant. So what I can understand, the resistive force always try to decrease your energy, right? So it does negative work, or in other words, I can say resistive force does negative work. So total energy at highest point, if I say, what is the highest point? Total energy is constant. Highest point total energy is how much? PE max plus what is the kinetic energy? 0. And at the lowest point, what is the potential energy? 0. But kinetic energy is how much? Half mv square. That we all know. Kinetic energy is what? Half mv square. Now, we have to understand here, in this part, if we calculate, we will see that whatever the maximum potential energy, the kinetic energy is not same. Why is so? Why is that? Because some amount of negative work has been done. Because some amount of negative work has been done. By whom? By the resistive force. So that means try to understand here PE max plus kinetic energy 0 plus work done by negative force or resistive force, that is equals to 0 plus half mv square. So total energy is what? Sum of potential energy, kinetic energy. This portion is potential energy. This is kinetic energy. This is kinetic energy at highest point. And this is negative work, resistive force. And this is at the lowest point. This is what? Potential energy at lowest point. And this is kinetic energy at lowest point. Okay, this is the lowest point. So if we try to do this, what we can get here, W is equals to half mv square minus PE max. Half mv square. Mass we have 3.35 10 to the power minus 5. V we have 10 square minus what is the potential energy at maximum height? 0.164. 0.164. So if I calculate this, what we get here, by calculating this one, we get so we get 3.35 10 to the power minus 5 into 100 divided by 2. 1 point. So we are getting here 0.00167 minus 0.164. So if we calculate this, we get minus 0.162 joule. So can you see what is the amount of work done? The amount of negative work is being done. This how much? That is equal to 0 minus 0.162. This is the amount of negative work is being done. Okay. So this question is a tricky. This question is a tricky. All of you, please, please see this question repeatedly. Try to understand. If you have any doubt, please let me know. Okay. Okay. Now we are moving to this question. So what about this question? Let us see this. What about this question? So here we are getting another part of this question. What will let us see? See, here we can understand. This is also a very tricky question. This is also from NCERT. We have to understand. See, we have total energy. What is the concept of total energy? Let me write over here. What is the concept of total energy? Let me just make it over here. Okay. Total energy is what? Potential energy plus kinetic energy. Potential energy plus kinetic energy, that is total energy. So at any situation, potential energy and kinetic energy always remain constant. So here the question is said the total energy of the particle is indicated by the cross. We can see here the total energy of the particle is indicated by the cross on the coordinate axis. See, here the examples of potential energy function is given. First of all, you will get confused what is potential energy function. Don't need to worry. Please see what is being given in the question. I am explaining now. Especially the regions, if any, which the particle cannot be found for the given energy. In case, specify the region. We have to specify the region where particle cannot be found. And also indicate the minimum total energy the particle must have in each case. Okay. So think of the physical context for which the potential energy shifts are relevant. Okay, we'll understand this. Just see, if I consider this, a particle can never be in a position, a particle can never be in a position where kinetic energy is negative. Okay, kinetic energy negative means what? That means if potential energy is greater than total energy, kinetic energy should be what? Negative. Yes or no? Just see. Is it possible? Is it possible? Total energy is equals to PE plus kinetic energy. So, can by any chance potential energy be greater than kinetic energy? No. Total energy, sorry, can potential energy be greater than total energy? No. Because total energy we are getting by sum of potential plus kinetic. By any chance, if potential becomes more than total energy, kinetic energy becomes negative, right? So this is the condition not possible for a particle, not possible for particle to be in that position. Okay, so particle cannot be in that position if total energy is greater than the kinetic energy. Clear? Now we will understand this. Now we will understand this. See this graph. We will just try to find out kinetic energy. Sorry, we will just try to find out where potential energy is greater than total energy. That means kinetic energy is negative. So it is not possible. I repeat, when potential energy is greater than total energy, kinetic energy is negative. So it is not possible. Right? Why? I have told you again. I'm repeating once again. Total energy is equal to sum of potential energy plus kinetic energy. By any chance, if potential energy becomes more than total energy, what we can understand? We can understand that means at that situation kinetic energy has become negative. Okay. Now see, we will check this portion. Here, what is the total energy position? This is the total energy, right? The moment the position is more than A at this region, can you see the potential energy has become more than the total energy. So what is the total energy portion? This is the total energy portion, this one. This is the portion where this is the total energy. Total energy. So the moment it crosses at this portion, here x is less than A, and at this portion x is greater than A. So when the position of the particle is more than A, we can see potential energy has become greater than total energy. Can you see the potential energy mark V naught is greater than total energy? So that means it is not possible for the particle to be in a state when the potential energy is more than total energy. So here for this graph, for the first graph, here potential energy is greater than total energy at x equal to greater than A. The moment the position is more than A, we can see what? We can see total energy is greater than, sorry, potential energy is greater than total energy. So in this situation, we have to understand a particle can never remain, a particle can never remain at x greater than A. Therefore, where is the position the particle can be? Therefore, particle should be at position x less than. Clear? Is it clear? Check this one. Check this. When x equal to 0, when x equal to 0, total energy is how much? This. The moment the position changes, like x equal to 1, 2, 3, 4, whatever, as the position changes, see, the potential energy becomes more than total energy. So here potential energy is always more than the total energy at each and every instant. Just see, at each and every instant potential energy is always more than the total energy. So here in this graph, a particle can never be in a position, particle can never be in a position, which position? At x greater than 0. The moment x is greater than 0, it is not possible for the particle to be there. But here also, if we check this in a precise way, when the at this position as well, just see at this position, here also the potential energy is what? Greater than total energy. Particle can never remain. So particle can never remain, can never be at x equal to 0, at x equal to less than 0. So that means this particle can never be in any position that x equal to greater than 0 or x less than 0. Because in both the cases, what we get to see, we get to see that the potential energy is greater than the total energy. Clear? Now we move to this question. Here, can you tell me? At this position, when x is greater than A, can you see? Potential energy becomes less than total energy. Again, when x is greater than B, potential energy becomes more than total energy. So which portion the particle can be? the particle can be only remain in these two, in this position. The particle can only remain in this position. What is the meaning of that? That means for this, particle can be present where at x is greater than a and x less than b. So that means x greater than a and x less than b is the possibility where the particle can be present. Why? What we have to look here? We have to only look the position. A position where potential energy is more than total energy, not possible for a particle. Potential energy more than total energy means what? Kinetic energy negative, not possible. At this position, what is the potential energy? Here, V naught. Is it greater than total energy? Yes, not possible. At this position, what is the total potential energy? Minus V1. Is it greater than total energy? No, that means particle can remain. Got it? Last one, you check here. Here, what we can understand, at this position, x greater than a by 2, this is x greater than a by 2, is this position, what is the potential energy greater than total energy? Not possible. So just see, we have to be very clear. Just see, if I just make this diagram a bit bigger, so that means we have to understand this portion. At this portion, you can understand the moment position x is greater than b by 2. That means which position? This position. Greater than b by 2. What can you see? The potential energy becoming less than, potential energy is becoming less than total energy, possible. But x less than a by 2 at this position also. What is the potential energy? See, negative. This is the potential energy. This is what? Negative. Less than a by 2. This is the potential energy is what? Negative. Here also it is possible. So it is possible for which two cases? When x less than a by 2 and x greater than b by 2. And here this portion, when x is less than, or we can say when x greater than minus a by 2 and x less than minus b by 2. So here also, when x is less than minus b by 2, potential energy is less than total energy possible. And also when x greater than minus a by 2, this is the position, potential energy is less than total energy is possible, right? So which portion is not possible? This portion is not possible. At this portion, we can see potential energy is more than the total energy. I have drawn with the colors as well. Is it clear? Okay, this is question. Again, this is a similar concept question. Let us see what we can do here. So in this question, what we can do here, please see, it is told the potential energy function of a particle executing simple harmonic motion is given by, what is the simple harmonic motion given by? It is given by Vx is equal to half kx square. So potential energy at any instant, at any instant half kx square, right? What is the value of k? K is equal to 0.5. Newton per meter. Okay. Now they have asked, show that a particle of total energy, show that a particle of total energy of 1 joule moving under this potential must turn back when it is reaches x equal to plus minus 2. So what is the total energy given? Total energy is equals to 1 joule. So a particle can have maximum potential energy, maximum potential energy is equals to how much? 1 joule. Okay. So that means Vmax can be maximum 1 joule, because last question only we have learned, last question we have learned potential energy cannot be more than total energy, because the position when potential energy increases to more than total energy, or potential energy becomes more than total energy, a particle can never be there, right? So what is Vmax? We can write, what is the expression of potential energy? Half k x square is equals to 1. K value is how much? 0.5. X square is equals to 2. So from here we can write x square is equals to 2 divided by 0.5. So that is 2 by 0.5 means what? 2 by 0.5 means what? 5 by, that is equals to how much? 4. So x is equals to, x square is equal to 4. So x equal to, we are getting plus minus 2. So the particle can go maximum distance of how much? X equal to plus minus 2. If x is more than plus 2, what can be potential energy? Potential energy becomes more than 1 joule? Not possible. Potential energy becomes more than total energy? Not possible. Similarly, if x is less than minus 2, potential energy becomes again more than total energy? Not possible. So the particle has to remain within which two portion? The particle has to remain, the particle has to remain in between x, this portion. Okay, the particle has to remain in between this. Got it? Clear? Okay, this is again same type of question from the previous part. What we have to do, we have to find out the work done by the force on the body. Again, what is given? This is not a force displacement graph, this is acceleration displacement graph. So can you tell me, if acceleration is given, can I find out the value of force? Yes, I can find out. So just see, force is what? Mass into acceleration, right? Force is mass into acceleration. See, this is acceleration time graph given now. Can you see this is acceleration time graph given? Okay. Now, force is mass into acceleration. So when I'm going to do the area, so work done by the force on the body when it reaches x equal to 4. So when it reaches x equal to 4. So force displacement graph, mass is given how much? 2 kg. So don't you think Acceleration, if it is given, acceleration versus displacement graph. How can we get this? We can get it in this following manner. Just see, work done, what we can do, what we have found out. W is equals to F dot ds. We can say F is equals to what? Ma dot ds. So therefore, work done, we can write mass is constant, A dot ds. So if we can do, now integration of anything gives us the idea of force displacement graph. Sorry, integration of anything gives us idea of the area under curve. So mass into integration of A dot ds, right? So if I can find out, so work done, we can find out mass into, here I can write area under acceleration displacement graph. Clear? Why? Because m is constant and here I am getting what? Integration of A dot ds. So why I am doing this here? Because area displacement graph is given. So first question given x equal to 4. The work done by the force on the body when it reaches x equal to 4. So x equal to 4 means what? This is the area that I have to consider. What is this? Trapezium. So work done, we will do what? Mass 2 kg into area of trapezium that I have shaded just now. So what can it be? 2 into area under shaded trapezium. 2 into what is the area? Half sum of parallel side. What is the sum of parallel side? That is 0 to 4, 4. And this one is 1 to 4. That is how much? 1, 2, 3. Into distance between them. What is the distance? 6. So if I try to find out what we are getting, 6 sevens are 42 Newton. This is the work done. So this is the work done by the force on the body when it reaches 4 meter. And next they have asked, what is it? Next they are asking, what next that is asked over here? It is asked work done when it is reaches 7. How can we find out what is the work done when it has reached 7? 7 mark, can you understand which is the 7 mark here? This is the 7 mark. So how can we calculate this? Please see. See, when we are trying to find out 7, that means we have to calculate the total area. So we have to calculate this area and also this area. So basically we have to shade, we will add the red color portion plus the green color portion, and then we will go for subtraction of which portion? We will go for subtraction of the blue color portion. Why are we doing this? Why are we subtracting blue color portion? Because see, over there the acceleration is what? Acceleration is negative. Over there acceleration is what? Negative. So acceleration is negative, that means over there if we calculate, we will be getting what type of work? We will be getting negative work done, right? So first one we have got 42 joule, right? first of all, we have got how much? 42 joule. Sorry, here it will be 42 joule. So next one we will be doing, next situation, this is for the first, and for the next we will be doing, so here we will be adding the entire trapezium on that upward portion. So what we can say here, network, sorry, this has become network, let me write work done, mass into, what is the mass? 2. What we can do here, sum of area of above trapezium minus area of lower trapezium. So when we do that, what is the area of above trapezium? Half sum of parallel side. What is the sum of parallel side? Total is, this is how much? 5, and this is 3. 5 plus 3. Understood? This is 3, and this 0 to entire portion is what? 5. Into distance is how much? 6. Minus, what is the 2? What is this? Sum of parallel side. This is what? 5, 6, 7. That is 2 plus this one is what? 1. What is the distance between them? What is the distance between them? 6. Okay. So if I take half common from both these two, and it comes out, we'll get what? 2 gets cancelled. 5 plus 3 is how much? 8. 6 into 8, and this is how much? 3 into 6. So this 2 gets cancelled. We are getting 48 minus 3 6 or 18. We are getting how much? We are getting 30 joule. Is it clear? Okay, so now we are doing this question. Let's see what is given. Here we can see a car of mass 1000 kg is moving with a speed of 18 km per hour. So think in this way. Suppose if I consider this to be a car, so a car of mass is, let me just get a car over here. Okay, I have got a car. So this car is moving with a speed of 18 km per hour on a smooth road and colliding with a horizontally mounted spring. So how does horizontally mounted spring looks like? This is a horizontally mounted spring. Okay. Now spring constant given is equals to given how much? 6.25 10 to the power 3 Newton per meter, and coefficient of friction between tire and the surface is 0.5. Okay. Now just see one thing. When this car is going to come and compress the spring means what? Don't you think it will be something like that? That this is the spring and this will get compressed like this, and this car is going to compress. So that means when this car is going on, it is moving a certain distance of how much? X. And when it is going on, compressing it, it experiences a frictional force. It experiences a frictional force, right? So what is going on here? The car moving with certain kinetic energy, the car moving in certain kinetic energy, that is being used in two purpose. What one purpose? One purpose is overcoming frictional force, and another purpose is doing work against
This another part of kinetic energy is used to compress spring and convert to potential energy. So that means when this car is compressing the spring, a part of the kinetic energy is being transferred to potential energy stored in the spring, as well as some amount of energy is used to overcome the friction. Now, what is the value of friction? Friction should be equals to how much? Mu n. So if this is mg, this is n. So F should be equals to how much? Mu mg. Mu is how much? 0.5. M is how much? 1000. G is how much? 9.8. So we get, if we calculate this, we get 4900 Newton is the frictional force. So we can understand then what is the velocity given. Velocity is given how much? So if I just write over here, velocity is given 18 kilometer per hour. That is equals to 18 into 5 by 18, that is equals to 5 kilometer per hour. That is 5 meter per second. And mass is how much? 1000 kg. Okay. So what we have to understand then, the kinetic energy that is being used for two purposes, that is potential energy. Kinetic energy is used to store it as potential energy, as well as work done in overcoming the friction. That is how much? F into x. Force of friction doing work, F into s. So we can write here kinetic energy half mv square, that is equals to potential energy half kx square plus F dot s. So if we take this two common as half common from both sides, or we can take or multiply 2 in both sides, we get mv square is equals to kx square plus 2f dot s. Now we have to find out the value of, sorry, this is x, this should be x. We have to find out the value of x, right? How can we find out? Mass is given how much? Mass is given 1000. Velocity is given how much? 5 square 25. K is given 6250 x square plus force of friction is given how much? 2 into 4900 x. So we are getting 6250 x square plus 9800 x minus 25000 is equal to 0. So from here, can we cancel 0, right? And then if we can divide with 5, what we can get here, just see, 125 x square, 125 x square plus 980x minus 1250, correct? Minus 1250. Oh, sorry, why it should be 980? I'm dividing with 5, right? So if I'm dividing it with 5, we are getting how much? 164. Sorry, 196. 196x is equal to 0. Okay. So now from here, how can we calculate? Is it possible for us to calculate from here? we can use Siddharacharya's formula, or let me just see if I can. Okay, let's see how to solve this one. So if we get over here, so x square we don't know, so let's use Siddharacharya's formula. Or if I go for this one, let me just check once. Okay, if I go and use the Siddharacharya's formula, we get x equal to minus b plus minus root over b square minus 4ac by twice a. B square minus 4ac by twice a. So if I use this, what we are going to get here? We are going to get x equal to minus b, that is minus 196, plus minus root over b square is how much? 196 square, minus 4ac. 4a is how much? 125, 1250, right? 1250. Now here minus is there na, so that's why this will become plus divided by twice a. Again a is how much? 125. So if we go for this, we are getting a huge value. So let me just do the calculation. You don't get scared about the values. Please see how we are solving it. Okay, the solving method is very important. The concept is more important. We are getting here 663416 by 1250 means 250, right? So we are getting root over this value, we are getting minus 196 plus minus 814.5 by 250. See, x can we, if we take minus here, we are going to get minus x. So we don't need to get minus x, we'll get a plus 1. So we are getting minus 196 plus 814.5 by 250. Minus why I'm not taking? Because we are, here x cannot be negative, right? The compression cannot be negative. So that's why minus 196. So we are getting here 814.5 minus 196 divided by 250. We are getting here 2 point, we are getting here 2.474 meter. As per as I consider, I think here the value of g should be taken 10 meter per second. Then this question would have been a bit easier. Since it is not taken 10, it is coming this value. I think the answer here is taken 10. Let me just clarify here once. If g is taken as 10, then here the frictional force would have become how much? Then frictional force would have become 0.5. We would have got how much? 5000 Newton. So now if I do the calculation, therefore if I go for this equation, what we would have got? 6250 x square plus 2 into 5000 x minus 2500 equal to 0. So this will get how much? 6250 x square plus this is, we would have got 10,000x minus 25,000 is equal to 0. So if I go for this, we would have got 625 x square plus 1000 x minus 2500 equal to 0. If I take here, 25 common, we would have got 25x square plus 80, right? Sorry, not 80, very sorry, plus 40x minus 100 is equals to 0. I think we can further cancel it. 5x square plus 8x minus 20 is equal to 0. Now if we go for the Siddharacharya's formula, the value would have been much easier. B square minus 4ac, 4 5 into 20. This has become plus because c is minus. So we are getting how much? Minus 8 plus minus root over b square is 64 plus 4. So 520, this is 400 by 10. So we are getting how much? 64 plus 400, 464. We are getting minus 8 plus minus 21.54 by 10. We are not going to take the minus, so 21.54 minus 8, we are getting, yes. Is it clear? Please don't get scared. Here the value of G, if I just change with to 9.8 or 10, it is becoming a huge difference. Okay, please check this part. Next, this question is very easy. What about this question? Again, the same thing. I'm not going to go in details. Here, displacement you have to find out by the method R2 minus R1. R2 is what? 14 I cap plus 13 j cap plus 9 k cap minus R1 is how much? 3 I cap plus 2 j cap minus 6 k cap. So if I go for this, we are getting 11 I cap plus 11 j cap, and this one is how much we are getting? Plus 15 k cap, right? This is what I am getting. So now work done will be how much? F dot S. So F we have how much? What is S? Just now we got 11 I cap plus 11 j cap plus 15 k cap. Okay, please calculate this. You'll get the value as 100 Newton. How? 44, here is 11, 50. So if we are doing this, we are sorry, 44. What is the value of J here? So, oh, very sorry here. This is not 6. This is what? It's fine. So we are getting here R2 minus R1, 14 minus 3, 11. Okay. Okay. And this is how much? 45. So we are getting how much? 44 plus 11, that is, this is 55 plus 45. 100 joule. Okay. So this question, I think it's very easy question. This is coming from the part of, we say, this one, collision. What is that? A sphere of mass moving with this is one ball, this is another ball. Okay. So what we can see, a sphere of mass moving with m with the velocity u hits another stationary sphere of same mass. So what we can say, what is the mass of this? This is m, this is also m. So this is moving with velocity u and this velocity is what? 0. After collision, what will be the value? So just see what is E here. We will consider nothing told about elastic or inelastic. It is nothing told. Elastic or inelastic, nothing is told. So what we can say, in case of collision, what remains same? Momentum remains same. Momentum remains same. So if momentum remains same, what I can say? Initial momentum should be equals to what? Final momentum. That means by conservation of momentum, of momentum, what I can say? m1 u1 plus m2 u2, that is equals to m1 v1 plus m2 v2. So what is m1 m, what is u1 u, what is m2 0, sorry, m2 is there but u2 is 0, so this part becomes 0. This is what? M, this is what? v1 and this is m v2. Why I am writing m? Because the mass is same. So if I take them common, m from both sides, we are getting u is equals to v1 plus v2. So this is my equation 1. Another thing we know, coefficient of restitution. What is coefficient of restitution? E. E is called relative velocity of separation by relative velocity of approach. That is v2 minus v1 by u1 minus u2. This whole comes under mod. Mod means we will take positive value. So u can be written as v2 minus v1 by u1. What is the initial velocity? U. What is the final velocity? u2 is what? 0. Sorry, initial velocity of body 2 is what? 0. So from here, what I can write, v2 minus v1, that is equals to E into u, right? So this is question 2. So if I add both of them, adding equation 1 and 2, what you get? Just see, if I add both of them, that is v1 plus v2 is equals to u and v2 minus v1 is equals to eu. If I add them, what am I getting? v1 getting cancelled and we are getting 2v2 is equals to u plus eu. So v2 becomes u by 2 into 1 plus. This is become v2. So can I put this, putting this in equation 1, can I find out v1? Yes, I can find out v1. Therefore, v1 will be how much? U minus v2. So v1 will be from equation 1, just see, from equation 1, u minus v2, this is v1. So u minus v2, what is v2 minus v2? We are getting, just now we have got u by 2 into 1 plus e. So if I do this, I'm going to get how much? 2u minus u minus e by 2. So we are getting u minus eu by 2, that is u by 2 1 minus. So therefore we have to find out the ratio of the velocities of two sphere after collision. So final velocity, what I can get, v2 by v1, if I do, we are going to how much, u by 2 1 plus e by u by 2 1 minus e. So that is we are getting 1 plus e by 1 minus e. Clear? Please check this question, see repeatedly. If you have any doubt, you tell me. Now this question is very easy. Remember, in class only I have told you to write one formula. H1 is equals to E square, sorry, H2 is equal to E square H1. What is this all about? Suppose if a ball is dropping from a height, what is the height it is coming from? It is dropping from a height H1. Okay, after collision it is going to rebound where? After collision it is going to rebound over here, H2. So how can we get? This is the formula. So H2 is equals to E square into H1. So here this is told H1 is given in this question is how much? 3.6 and H2 is how much? 1.6. So therefore we can find out E square is equals to H2 by H1, or we can say E square is equals to H2 is how much? 1.6 by 3.6, right? Therefore E square is equals to root over 1.6 by 3.6. So if the point goes away, we get 4 by 6, that is 2 by 3, that is 0.67. Remember, E does not have any type of unit. Okay. So this will be the last question, and this question I hope you all can understand. This question is a bit tricky. Let's see what is going on. This is a block which is suspended. Okay. Now a small bullet hits this. As a result, what happens? This block, it moves to a height like this. As a result, what happens? This block moves to a height like this. Okay. So we have to understand this here. So that means why this block is moving at this height? What is the height? Let us find out. The height is given as how much? The center of gravity of the block raises by height 0.1 meter. So it raises by 0.1 meter. So that means one thing is clear. When the bullet hits the block, when the bullet hits the block, velocity gained by block, velocity gained by block is used to increase potential energy. Why? When it is going up, its potential energy, it's increasing. So what I can say, half mv square is equals to mgh. So what is v here? V is the velocity of block. Okay. So block mass is how much given in the question? Please see. Mass is given how much? Block mass is given 2 kg. So we can say this is a 2 kg block. So mm gets cancelled. So from here, v square, v becomes root over 2gh. V becomes root over 2gh. Okay. So now v becomes root over 2gh. What we can say here, g is 9.8. What is the height does it go? 0.1. That is 1.96, right? So that is, it is going how much? What is the velocity? 1.4 meter per second. This is the velocity with which the block experience. Now the question is initial velocity. So this is about the block. This is all about the block. But what does the question ask? So this is what? Velocity of block just after hit by bullet. Now the question is asked, what is the speed of the bullet after it emerges out of the block? So what is the initial mass? What is the initial mass of bullet? MB I am writing. How much? 0.01 kg. What is the speed with which is coming? U1, 500 meter per second, right? Now, by conservation of momentum, we can write by conservation of momentum, what we can write? Initial momentum of the bullet is how much? MB U1. And what is the initial momentum of the block? Mass of the block m into 0. No velocity was there. After striking, what is the mass of the block is m? What is the velocity it gained? That is v. That's what we have found out. Plus, what is the mass of the bullet mb? That is v dash. So we have to find out what? We have to find out this v dash. Now see, mass of the bullet mb is 0.01, u1 is 500, this is 0, mass of the block is 2 kg, that is into velocity is 1.4, this is mass of the bullet is 0.01 into v dash. So we can find out. So we are getting 5, and this is how much? 2 into 4, that is 2.8 plus v plus 0.01 v dash, right? So here 5 minus 2.8 is equal to 0.01 v dash. So this is coming out to be how much? 2.2 is equal to 0.01 v dash. Therefore, v dash is equal to 2.2 by 0.01. So v dash coming out to be 220 meter per second. Is it clear? Okay. So let me see any more question is there or not. Okay. This question is very easy. This one is also easy. This one is also easy. These questions you should be doing. Okay. Achha, I'm just showing this one. This should be the last one. Okay. What is given? A body of mass m is at rest. Okay, fine. This is a body of mass m is at rest. So this one m is at rest and this one is over here. This is m. Velocity is 0. And this is moving body. This is moving with some velocity u1. Proof that the fraction of initial kinetic energy of mass m transferred to struck body is this. Okay, we can prove this. We can prove in elastic collision. So elastic collision, what I can find out? V2, remember the formula? M2 minus M1 by M1 plus M2 into U2 plus 2M1 U1 by M1 plus M2. So why I'm trying to find out V2? Because I'm trying to find out the final kinetic energy gained by the body, this one, the body 2, that is the capital M mass. So V2 will become, this part will become what? 0. This first part will become 0 since U2 is 0. So 0 plus 2, this is small m, this is U1 by small m plus capital M. So this is V2. Okay. Now, what is the initial kinetic energy of the body? Initial kinetic energy of kinetic energy I, initial kinetic energy. Only this one was moving, right? So half m u1 square, and therefore what is the kinetic energy gained by mass capital M? What I can say? Half capital M v2 square. This is the velocity with which it gained after collision. What is v2 then? 2m u1 by small m plus capital M whole square. So if I do this, I'm going to get half capital M into 4 small m square u1 square divided by m plus capital. Is it clear? Now the question is, prove the fraction of initial kinetic energy of mass m transferred to struck body. So that is out of how much this is being transferred, right? How much? So if I try to find out fraction of initial kinetic energy, the struck body, how can I find out? That is kinetic energy of the body 2. I can do it in this way. This is K2, that is kinetic energy of the body 2 by K1, that is the kinetic energy of the body 1. If I go for this ratio, I will be getting half capital M 4 small m square u1 square by small m plus capital M whole square, right? Whole divided by, what is this? Small m u1 square. Okay. So if I take this, half gets cancelled, small m 1m cancels, u1 square gets cancelled. So we can get, therefore, K2 by K1 is equals to how much we are getting? 4 small m capital M by small m plus capital M. Is it clear? Okay. So we are keeping until this much. Please see the videos and let me know if you have any doubt. Thank you.